Hello everyone, welcome back to Ansarkari. So we are continuing with the classical oligopoly models, which are specifically related to duopoly models. So previously we have covered the kinked demand curve theory, which talks about the stickiness in the nature of the prices, and prices they exist or they are stabilized at the prevailing market prices itself. There is no divergence from that. Secondly, we covered with the Bertrand model where we discussed about the reaction curve approach, and there we see that price is the adjusting factor. Thirdly, we took up the Edgeworth model where we again understood through the mirror type of graph, which was triangle shaped, how there is always perpetual disequilibrium in the market, and the market prices keep oscillating between the perfect competition prices and the monopoly prices. That is why there is perpetual disequilibrium. So today we will see another classical duopoly model, which is the Cournot's model. So here first we'll see few of the assumptions. So Cournot assumed that quantity is the adjusting factor in the market. So it is analyzing the demand side of the economy. Second, we have homogeneous goods in the market. Thirdly, we see that there are two players because it is duopoly. So player A and B, they are identical in nature. Identical, which means that the cost conditions are also same. Costs are same for both the players. They will be producing equal amount of output because it is identical. So the profit will also be divided between both the players. And the sole aim is maximization of profits under the duopoly. And we see there is zero mutual interdependence. Between both the players. Now let's understand how it operates and how it works. So on y-axis, we have the prices. On x-axis, we plot the quantity. So let's suppose this is one of the demand curve of player A, MD. And correspondingly, we draw the marginal revenue curve of firm A. So it will be producing at this level, say ON would be the quantity, prices would be given by the demand curve. So this point, let's suppose this is K. Now this is for only single player. When only firm A is entering the market, which is the first one to enter the market, it will produce ON level of output, which is also the monopoly level of output because it is the only player in the market. So this is the monopoly level of output, and correspondingly the price that would be charged will be OP price level. Now we see the second player, which is player B, will enter the market, and for it the demand curve for player B is the KD section. So KD section is the demand curve, and correspondingly we will draw its marginal revenue curve, which is MRB. MRB. Now this point, let's suppose it is point H. We will draw corresponding price level. This is, let's say, P dash. So OP dash is the price level, and OH is the complete output of both the players when there is duopoly in the economy of the market that is operating. Now let's suppose here when we see that where the total output that can be produced is OD. So OD is also the competitive level of output, competitive or the output that is produced under the perfect competition. Here the price is 0. Now when firm A was producing ON, so ON is half of OD. And when we see that two players are there, at that point of time, we saw OH is the total level of initial output that is being produced, and OH is 2/3 of OD. Now we will see it with more clarity, let's understand how the firms they will be reacting. So initially A is at ON. After this, B will be producing the NH section. So only section for player B is this NH, which is being represented here. Now, when B is producing NH, we see that there is fall in the profit of firm A. So we label this and then we'll understand how the profit falls. So profit for firm A would be only this section ONGP dash. Earlier the profit for A was ONKP, which is clearly higher than what it is now earning as a profit once the second player enters the market. And the profit for B is NHL G. So this is G point. So this is the profit level for firm B. So they would be reacting to each other once now firm B is producing NH. Again, firm A profit level falls. So A will again reconsider the situation. What should be its output level now? Because output is the adjusting factor under the Cournot's model. So A would now, there's a formula which is there that on the basis of which the output is decided, which is equal to half of the total output, which is OD, minus what is the current level of output being produced by the rival firm, which is NH currently. NH is the production of B. So this is the new output of A. So this reaction goes on and we see that in the end, they will stop once we see that the K level, or we can say again in the end, there would be three sections which would be achieved in this case. Let's say if we have to represent. So let's say this is C, this is P double dash. So when the total output together of both the firms reaches OH section, which is, you can see that OC is equal to CH is equal to HD. That is why we can say that OH is also equal to 2/3 of OD. And since we saw that both the firms are identical in nature, so OC is equal to CH. So OC becomes the equilibrium or equilibrium output of one of the firms, and this is CH is for the second firm which is there. So hence we say that now we achieve the stable equilibrium state. So at stable equilibrium, the firms do not have any incentive to change from the current position at which they are producing. That is why it is known as stable in nature. Now we can compare the Cournot's model and the outcomes with that under the monopoly. So let's say equilibrium output under Cournot is the OT part. This is OT. And under monopoly, it is ON. As we saw that when A was the only player, ON was the total output, which was the monopoly output at which it was earning maximum level of profit. When we compare, let's say, the equilibrium prices, so under Cournot, the equilibrium prices is this OP dash in the end, OP double dash. And for monopoly, you can see for ON level of output, it is matching the OP level. So you can see that price level is higher under monopoly. It is higher compared to the Cournot's model, and output is less in case of monopoly when we are comparing with the OT section. Now, one more thing can be the profits and the comparison. So under Cournot, when OT is the final output level, you can see OT, let's say this is S. OTSP double dash is the profit. Under monopoly, profit would be ONKP area. ONKP area. So you can see profits are maximized by monopoly when it is producing less, but it is selling this at a higher price. So this is one comparison that can be drawn. Now this is for only two players because we are studying duopoly. What suppose if we say that there are three players in the market or more than three players, how we will decide the equilibrium output? So as we saw the formula, so in this case if there are three players, so it becomes 3 by 4th of the total output would be produced together by the three players. If there are four players, so it would be 4/5. So you just have to add 1 in the denominator. So that is one simple way. Now we also say that Cournot equilibrium, can we call it to be the Nash equilibrium or not? So here, what is the meaning of Nash equilibrium? Nash equilibrium simply states that the firm is performing at its best level, and the best level is when it is able to maximize its profits given the other players, what are they producing, what amount, and at what price are they selling that. So given we have these two factors, the firm is able to maximize its own profit. At that point of time, we say that firm is at its Nash equilibrium. So for this, we have one mathematical illustration, also the general illustration if we have to do for the Cournot. So in this case, we assume the linear demand function, which can be, it is generally written as A minus B Q. Q is the total quantity, P is the price level, A is the one, it's a constant, and minus B is representing the slope. So since we have two players, so we can write quantity as QA for player A, QB is the quantity of player B. So that's how we can write. For further again reaching the equilibrium, in the end what we have to calculate is equilibrium price and the output. So for that we need to have the total revenue equation. So total revenue, simple formula is price into the quantity. This is for, let's say, player A we are calculating first. So we have this price equation, quantity A would be multiplied. So when you do this, we simply am writing it directly, what would be the end form. A multiplied with QA minus B QA square would be there, and minus B QA QB. So this is the total revenue of A. Now when you differentiate this with quantity A, we get marginal revenue of A. So for this, you need to know simple rules related to differentiation. So when you're differentiating this equation, we get it in the form of A minus 2BQA minus BQB. So this would be left, and this is the marginal revenue. And equilibrium is when marginal revenue equals the marginal cost. Marginal cost remains constant, so we can assume that marginal cost is K, which is a constant number that would be given to us in the numerical, which does not change. So when we equate this equation with the marginal cost, which is K, A minus 2BQA minus BQB, we have to get the value of QA. This is the equilibrium quantity. So when you solve this further, A minus K minus B QB would be there, and 2B. So this is the reaction equation of A. And we have to calculate for player B. So we just have to swap the symbols. A minus K remains same, minus B, it becomes QA here, and 2A. So that's how it changes, or it is, because it is identical, so we just have to swap the symbols which are there. When we solve these two equations, now we will get what would be the equilibrium quantity of A. That would be same as QB, and profits can be calculated. This is symbol for profit, total revenue minus total cost. That would be equally divided between both the players. So since this is the reaction equation, so let's understand this through graph also, reaction curve approach. So if you remember, we have previously covered the reaction curve approach under the Bertrand model also. But there the difference was, although it was reaction curve approach, their price was the adjusting factor. Price was, it was adjusting. And in the graph also, when we drew the graph, here we plotted price of firm A, price of firm B. But in this case, if you remember in the beginning, we stated it is quantity which is the adjusting factor. So you simply plot quantity of firm A and quantity of firm B instead of the prices. So we draw the reaction curves. This is for firm A. Let's suppose label at NM, and another reaction curve for B would be drawn like this, intersecting at E. This is, let's say, RS. This is A's reaction curve. This is B's reaction curve. Now, let me first label this. M point is also A1 point. Then we draw from equilibrium also. This is AN and this is BN in between. At intersection here also, there would be one point. This is B2. So you can see B1, B2, Bn. In case of A, it would be A2 here. And one would be this point. So this is A3. So AN, A3, A2, A1. A1 is also M. So if you see that, let's suppose, first that the two forms, they're identical. So OM is equal to OR section on the graph and ON is equal to OS section. O is this origin point. So this is also one given thing. Now here we see if B is producing OB1, this section, you can see where does it stop on the A's reaction curve. It will stop at this point. So correspondingly on the x-axis, we have A will produce OA2 part. So this is in reaction to what B is producing in the beginning. Or just for understanding, we will start with A, and before that, also monopoly output would be produced by A, which is the OM section again. OM represents the monopoly output by A because here B is producing 0. Now, in monopoly, only one player is there in the market. So that is why when B produces 0, A produces OM. This is the monopoly output. Now, how do we reach equilibrium? Through the reaction curve approach. So A is producing OM. We start from this point only, which is the monopoly equilibrium point. It is the only player which is there in the market. Now B enters. So B assumes that since A is already at OM, it will not change the decision. And correspondingly, in reaction to OM, you can see here B will produce OB1 level of output. Now, since A's profit reduces, so A will again reconsider the situation and assumes that when B is already producing OB1 level of output, now corresponding to OB1, A will produce OA2 part. So this goes on, and now if A is at OA2, B assume that it will not change from here, and B will now, in reaction to A's production of OA2 level, you can see OA2. So here, this is the point on B's reaction curve. B will now produce OB2. So this process goes on until both the players reach point E, where A produces OAN, B produces OB n level of output level. So that's how they reach their equilibrium quantities. Here, one critique we can say is that initially in the assumptions we assumed that the firms are they are not mutually interdependent, but what you can see is that they are considering what is others output level. But in the assumption we assumed that they are not interdependent, they are taking their decisions independently. However, the working is not suggesting us so that assumption breaks down, and this becomes one of the critiques. Second would be that it is like, even if they are considering what the other firm is producing, the quantity that they're deciding to produce, they're still not learning from their experience. So that is why this model is also known as no learning by doing model. They're repeating the same mistake in a way again and again. That is why we have this another name. Now, if we see that there have been questions asked from this model, and one is the numerical. So if we solve one simple question, so we are given with the demand equation, P equals to 100 minus Q. This is given, and marginal cost for both the firms the same, which is equal to 2. That is also given, or we can take it to be 10 to simplify but this is marginal cost. So we calculate the total revenue here for firm A. So we multiply P into QA. We'll see total revenue would be 100 QA minus, since this can be QA plus Q2 when we further break it down. So minus QA square minus QA QP. Now marginal revenue for A would be differentiating this equation. So it would be 100 minus 2 QA minus QB. So this is the marginal revenue equation. We equate marginal revenue equal to the marginal cost, which is given to be 10 to us, to get the equilibrium or the reaction curve equation. So 100 minus 2 QA minus QB equals to 10. When we solve it for QA through this, we see 90 minus QB upon 2. So further we can write this as 45 minus QB by 2. So this is the reaction curve equation. This is also asked in the examination. Reaction curve equation of A. And for B, we can write this as QB. We just have to swap again the symbols. QA upon 2. Numericals remain the same that we have derived. Now we solve these two equations to get the value of QA and QB. So QA, we will put the value of QB here. So half is there, 45 minus QA by 2. When you solve this further, we 45 by 2 plus QA by 4. So QA is taken this side, QA minus QA be 90 minus, no, it would be 45 only, 45 by 2. And this becomes 3QA by 4. And we have 45 by 2. So we get the value of QA when you solve it. 4 by 3, 2. In QA would be 30. And since both the players are identical, so QB would also be 30. Now price would be calculated from the equation that we were given. So Q here is 30 plus 30 of these two. So it would be 60. So 100 minus 60. Price, equilibrium price would be 40. And this is equilibrium quantity. So that's how we can solve. And we can further compare now this model. So this is the Cournot's model output. Now we have to calculate for monopoly. So how it is changing numerically can also be assessed and analyzed. So in case of monopoly, when B will be producing 0, so what would be the output of A? So since we derived this equation, reaction curve of A was 45 minus QB by 2. So put QB equal to 0. You will get the output as 45. So you can see under the Cournot, the output 30 plus 30, 60 was the output. Under Monopoly, you can see it has reduced to 45 units. Price will be increasing here. And also for the perfect competition, usually we say it would be double that of the Monopoly. So here it would be 90, and if you have to calculate proper steps, it would be price equals to the marginal cost. So for price, we are given the equation 100 minus Q. Marginal cost is given to us as 10. So Q would be 90. Or when you do twice of this, Q 45 into 2, then also you will get 90. So this is under the perfect competition. Here you can see that if the firm they decide to collude, or they decide to work together, and then they are agreeing with the prices that are decided by them and producing at that level, even in that case we say they will be producing at the monopoly level of output, which is 45 units. So at 45 units, their profits would be more than what they would be earning under the Cournot's model. So this is one of the benefit if they both decide to work under a proper collusion in the market. And that's how we have compared the monopoly also perfect competition through one single equation also. So this is all about the Cournot and the previous models that we saw. And again, under the Cournot, homogeneous products are there, no mutual interdependence. Quantity is the adjusting factor, so that is one of the main points under this. And they are considering the reactions, although the assumption says that they are working independently, they are deciding the prices and the output independently. So that is all for today's video, and again we'll continue with the classical model in the next section, which is we will cover the Stackelberg model of duopoly. So thank you so much for joining us on Ansarkai, and stay tuned for further detailed sessions.